Assalamu alaikum to everyone. Our today's topic is measures of dispersion. We are going to discuss mean deviation today. This topic pertains to HSE Part I. We are going to discuss the meaning and the computation of the mean deviation. But before we will go through the computation of mean deviation in the individual, discrete and continuous series, let us have a brief reflection on the meaning of mean deviation. Mean deviation, popularly known as average deviation, and mean deviation is defined as the sum of deviations ignoring signs taken from an average divided by the number of observations, or you can say divided by the number of items or the values in a distribution. Or simply you can say we are adding up the deviations taken from actual mean, median or mode, and are dividing those deviations, sum of those deviations, with the number of items in a distribution. The average can be mean, median or mode. Most popularly, mean deviation is calculated by using arithmetic mean. Now, let us discuss how the mean deviation is calculated in the different series. For example, how we are calculating the mean deviation in an individual series, then how we are calculating the mean deviation in a discrete series, then we have to study how the mean deviation is calculated in a continuous series. Let us take one by one. We have three examples. Let's take first the example number 1. We have example number 1 here. Example number 1 is find the mean deviation about the mean for the following data. Or you can say you are asked to calculate mean deviation from the following individual series by mean. Our series is, the items of the series are 6, 7, 10, 12, 13, 4, 8 and 12. Before calculating mean deviation in this individual series, we have to study how we are calculating the mean. Mean of a given data is sum of all items divided by total number of items. Or you can say sum of observations divided by the number of observations. And we have the observations here. X bar denoting the arithmetic mean, or you can say simply you can say mean, is equal to, we are adding up the number of items, 6 plus 7 plus 10 plus 12 plus 13 plus 4 plus 8 plus 12 divided by the number of items, which are 8. 1, 2, 3, 4, 5, 6, 7, 8 are here. 1, 2, 3, 4, 5, 6, 7 and 8. So divided by 8. Summation of x divided by n. Summation of x is 6 plus 7 plus 10 plus 12 plus 13 plus 4 plus 8 plus 12 is equal to 72 divided by the number of items, which are 8. 72 divided by 8. Therefore, x bar is equal to 9, which means our arithmetic mean, or you can say mean, is 9. Now, let us calculate the mean deviation from mean. The formula for mean deviation is, you can write mean deviation, or symbolically you can write MD. MD is equal to summation of x1 minus x bar divided by n. x1, the variable in a series, x bar, the arithmetic mean. We are taking here the deviations from the mean, which is 9. We have the column here, 3 columns here in a table, column 1, column 2 and column 3. In the first column, we are taking x1. I mean to say number of items in a series, 6, 7, 10, 12, 13, 4, 8, 12. We have to calculate the deviations from these items in a variable, which is x1. We have the mean here 9. So we have to subtract this 9 from each value in the series. So see here, x minus x1 minus x bar. 6 minus 9 is equal to minus 3. 7 minus 9 minus 2. 10 minus 9 minus 1, 12 minus 9, 3, 13 minus 9, 4, 4 minus 9, minus 5, 8 minus 9, minus 1, 12 minus 9, 3. This is how deviations are taken from mean. But remember that while calculating mean deviation, we are ignoring the signs. Plus minus signs are ignored and all minus signs are taken as plus. So see here, instead of minus 3, we are ignoring the sign here. Simply it is 3. Minus 2, simply it is 2. 1, simply it is 1. 3 and 3. 4, 4. Instead of minus 5, we will write 5. Instead of minus 1, we will write 1. Instead of 3, we will write simply 3. So, calculating mean deviation, we have the formula MD is equal summation of x minus x bar divided by n. In the third column, we have x minus x bar. The deviations taken from arithmetic mean. We have to add up these deviations. 3 plus 2 plus 1 plus 3 plus 4 plus 5 plus 1 plus 3. Summation of x minus x bar is equal to 22. Coming towards the formula, MD is equal to summation of x 1 minus x bar divided by n. That is MD, I mean say mean deviation. Therefore, mean deviation is summation of x minus x bar is 22. 22 divided by the number of items, that is 8. 1, 2, 3, 4, 5, 6, 7, 8. 22 divided by 8. Therefore, our mean deviation in this individual series is 2.75. This is how mean deviation is calculated in individual series. We have example number 2 here. It is in the form of discrete series. We are asked to calculate the mean deviation from this discrete series. We have the discrete series here. Find the mean deviation about mean for the following data. We have the data x1, 2, 5, 6, 8, 10, 12. And we have f1, I mean to say the number of items. It is a discrete series. 2, 8, 10, 7, 8, 5. We have a table here containing 5 columns. First we will concentrate on first 2 columns. Number 1, x1, 2, 5, 6, 8, 10, 12. And f1, 2, 8, 10, 7, 8, 5. Before we will calculate the mean deviation, let us calculate the mean first. The formula is different here. It is a discrete series. For calculating mean, or you can say the arithmetic mean, we have x bar is equal to summation of f1 x1 divided by summation of f1, I mean to say number of items. So, we have to multiply f1 with x1, that is f1 x1. 2 2s are 4, 5 8s are 40, 6 10s are 60, 8 7s are 56, 10 8s are 80, 12 5s are 60. So our n is 2 plus 8 plus 10 plus 7 plus 8 plus 5 is equal to 40. You can say n, the number of items, or you can say summation of f1. Now we have summation of f1 x1, which we have multiplied here. 4 plus 40 plus 60 plus 56 plus 80 plus 60, which is equal to 300. So our summation of f1 x1 is 300. Now let us calculate the arithmetic mean. Instead of summation of f1 x1, we are writing 300, and instead of summation of f1, we are writing 40. 300 divided by 40, our mean is 7.5. Therefore, x bar is 7.5. Now we have to calculate the mean deviation, taking the deviations from the series which we have given. Our arithmetic mean is 7.5. So see here, x minus x bar. We have to subtract this x bar, I mean to say 7.5, from all items in x1. So 2 minus 7.5 is equal to minus 5.5. 5.5 minus 7.5 is equal to minus 2.5. 6 minus 7.5 is equal to minus 1.5. 8 minus 7.5 is equal to 0.5. 10 minus 7.5 is equal to 2.5. 12 minus 7.5 is equal to 4.5. So here we have some values, we have some deviation in the form of negative, but we have to neglect the negative side, we have to ignore the negative side. So see, instead of minus 5.5, we will write 5.5. Instead of minus 2.5, we will write 2.5. Instead of minus 1.5, we will write 1.5. And 0.5 is already positive, 2.5 is already positive, 4.5 is already positive. So our x minus x bar is 5.5, 2.5, 1.5, 0.5, 2.5, 4.5. Now we require summation of f1 into x1 minus x bar. So we have to multiply this x1 minus x bar with f1. 2 into 5.5 is equal to 11. This is f1 into x1 minus x bar. Then 5 into 2.5. 8 into 2.5, it is 20. Then 10 into 1.5, it is 15. 7 into 0.5, it is 3.5. 8 into 2.5, it is 20. 5 into 4.5, it is 22.5. So after multiplying f1 to x1 minus x bar, now we are adding up to get the summation of f1 into x1 minus x bar. That is 11 plus 20 plus 15 plus 3.5 plus 20 plus 22.5. That is equal to 92. Now calculate the mean deviation. Our formula is in discrete series MD is equal to summation of f1 into x1 minus x bar divided by n. That summation of f1 into x1 minus x bar is 92 divided by n is 40. Therefore, MD is equal to 2.3. Our mean deviation is 2.3. In discrete series, this is how mean deviation is calculated in a discrete series. Now we have example number 3 here. Find the mean deviation about the mean for the following data. This is a continuous series and we are asked to calculate the mean deviation in this series. We have marks in the grouped form. Yeah, marks, you can say marks obtained by the students 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70 and 70 to 80. We have the class intervals and we have the corresponding frequencies. Number of students 2, 3, 8, 14, 8, 3, 2. These are the frequencies against the each class interval. Against 10 to 20 we have the frequency 2, 20 to 30 we have the 3, 30 to 40 we have the frequency 8, 40 to 50 we have frequency 14, 50 to 60 we have frequency 8, 60 to 70 we have frequency 3, 70 to 80 we have frequency 2. Here, coming towards the solution, we have 6 columns in the table. Let's concentrate in first 2. Marks obtained 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70 and 70 to 80. And we have the F1 here. Number of students 2, 3, 8, 14, 8, 3, 2. We have written the values of the variable and the corresponding frequencies. Now, we have to calculate the midpoint or you can say the average. X1. For getting X1 or midpoint or mid value, we are adding up the lower limit of the class interval with that of the upper limit of the class interval divided by 2. Lower limit is 10 and upper limit is 20. 10 plus 20, it is 30 divided by 2, that is 15. 20 plus 30, that is 50 divided by 2, 25. 30 plus 40, that is 70 divided by 2, 35. 40 plus 50, it is 90 divided by 2, 45. 50 plus 60, it is 110 divided by 2, 55. 60 plus 70, it is 130 divided by 2, 65. 70 plus 80, it is 150 divided by 2, it is 75. Now we have here the midpoints in the form of x1. Now we will multiply x1 with f1, f1 x1. 2 into 15, 30. 3 into 25, 75. 8 into 35, 280. 14 into 45, 630. 8 into 55, 440. 3 into 65, 195. 2 into 75, 150. Now, let's add up these values, F1, X1, to get summation of F1, X1. 30 plus 75 plus 280 plus 630 plus 440 plus 195 plus 150. Summation of F1, X1 is equal to 1800. 1800. Let us calculate mean first. The formula in the continuous series to calculate the mean is X bar is equal to summation of F1, X1 divided by summation of F1. Summation of F1, X1 is 18 divided by summation of F is 40. 18 divided by 40, X bar is equal to 45. Therefore, mean is 45. Now we have to take the deviations from this mean, or you can say the arithmetic mean. X minus X bar. We are calculating the deviations from X1. X1 is this: 15, 25, 35, 45, 55, 65 and 75. We have to subtract 45 from all these values. First, 15 minus 45, it is minus 30. 25 minus 45, it is 20, minus 20. 35 minus 45, it is minus 10. 45 minus 45, it is 0. 55 minus 45, it is 10. 65 minus 45, it is 20. 75 minus 45 is 30. But don't forget, while calculating the mean deviation, we have to ignore the minus sign. See here, instead of minus 30, we will take 30. Instead of minus 20, we will take 20. Instead of minus 10, we will take 10. All other values are already positive. So, now we have to multiply X minus X1 minus X bar with that of F1. So frequencies are to be multiplied with X1 minus X bar. That is 2 into, instead of minus 30, we will take 30. 2 into 30, 60. 3 into 20, 60. 8 into 10, 80. 14 into 0, 0. 8 into 10, 80. 3 into 20, 60. 2 into 30, 60. We have got the multiplication of the deviations, and we will add up them to get summation of F1 into X1 minus X bar. That is 60 plus 60 plus 80 plus 0 plus 80 plus 60 plus 60. That is 400. Therefore, summation of F1 into X1 minus X bar is 400. The formula to calculate mean deviation is MD is equal to summation of F1 into X1 minus X bar divided by N. Our summation of F1 into X1 minus X bar is 400 divided by N is 40. 400 divided by 40. Therefore, mean deviation is 10. This is how mean deviation is calculated in a continuous series. Thank you very much.